That's where I'd like to start today. In case you didn't see it yesterday, by changing the temperatures of these two parts of a single body of water, I've made one part of that water hotter, one part of that water colder. By changing their temperatures, I'm going to make them move all the way from back here. And the reason that the timing is good to repeat this demo is that explains why the North Atlantic stays colder while the rest of the world gets hotter. This takes a lot of notes. I'm sorry, it's really tricky. Three-dimensional geography, climate. You might be good at three-dimensional, or you might be good at geography, or you might be good at climate, but this is all of that. So I gotta warn you, this is a tricky one. It's called the Ocean Conveyor Belt Current, number 17. Number 17, Ocean Conveyor Belt Current, number 17. Kind of see it just barely getting started to happen. I'll put a little paper on it. This might help. The bottom, the blue, is going to go that way. The red is going to go that way. I could roll my cart, but it's all going to wobble. Should I do it? Can everybody see where it is? Enough? Except for Serena, who cares? Anybody? Oh, it's already happening. Yeah, there we go. Look, you can see that the red is spreading over to the window and the blue is spreading over to the wall. Remember, by making this area colder and this area hotter, it's basically all this, by the way. Heat and pressure and high to low pressure. It's the same. This is your explanation right there. This is the same as this, you realize. Convection current, convection cell, same thing. This is the same way that a solar chimney works in there. We have a gigantic one of these that happens on our planet. Because, please look up, there's wind. And because the map has uneven distribution of land masses and oceans, some of those winds are moving more water than others, and some places they blow across the water, and some places they blow across the land. Okay, watch me. Because wind, we create areas of hotter and colder in the ocean. Because of wind. This is all driven by the North Atlantic Ocean, right here. There's a reason I drew this one. Look at me. I want everybody to watch. A lot of wind this way, a lot of wind that way. This part of the ocean gets really, really, really windy. Are we cool with that? Everybody understand that? Really windy? Geographically, this is the North Atlantic Ocean. Okay? So you gotta know, the North Atlantic Ocean is very, very windy. And anybody know what happens when you blow across the top of your hot soup or your hot oatmeal? Everybody understand that? That when you blow across your hot soup it gets colder? Please tell me you know what I'm talking about, for God's sake. Okay. Hey look, it's happening over here. You all see that? The waters are moving? That's cool, right? I haven't touched it. It was all standing still. I just poured the water and walked away. We'll come back. This is going to keep doing its thing. Here's like what happens over here. Because the North Atlantic gets colder, it's relatively hot surface water that gets blown across by really, really, really powerful winds in all directions over a big chunk of Atlantic Ocean. That water gets colder. What else happens? When you evaporate part of salt water, what are you left with? Saltier water, yes? And that's denser, right? Because it's water plus salt. That's more dense than just fresh water. Do you all agree with that? Yes? So, you must know that in the North Atlantic, water gets colder. That heat blows onto Europe. It's a heater for Europe because all that hot water vapor goes somewhere. It warms Europe's jet stream. Look at me, look at me. You see this arrow? That brings on shore to like England and stuff, hot water vapor. You take all this hot surface water and then you blow that heat onto the jet. So the water stays cold, the heat goes somewhere. Next, I want you to write down in your notes what's happening in two other places. In Alaska and in India, offshore wind pulls up cold water and it's going to get hotter because it's coming to the surface where there's sunlight. There's overall pretty strong upwelling regions in the general Alaska, what is that, Siberia? What's Siberia? Across the Pacific? Yeah, across from Alaska, Siberia, is that right? Yeah. I'm not very good at this. What's your face? Sarah Palin can see Russia from her front door or something? Siberia, Russia? Yeah, all right, there you go. So between Siberia and Alaska, you have a lot of upwelling, which brings cold water to the surface, and that's going to heat up at the surface. Just like in the North Indian Ocean. Does everybody know what India is? The little triangle notch thingy? There's like Australia, and there's like Africa, and then that triangle thingy is India, the snaggletooth. Okay, so right next to India in the North Indian Ocean, we have a lot of upwelling, and that's water getting hotter. And please look at me, look at me. What's going to happen to water that's been made colder or been made hotter? It's going to do what? It's going to sink or rise and move laterally. Everybody got that? So we have this thing called the ocean conveyor belt current. It's AKA, you might want to know this in case of the AP test getting nerdy on you, it's AKA the thermohaline current. That means temperature and salinity current. Thermohaline, temperature and salinity. Because it has differences in its temperature and in its salinity. That's all. Thermohaline? No, I didn't. Oh. Sure, thermohaline. Haline. Thermohaline. Temperature salinity. Haline, the thermohaline current. The ocean conveyor belt current. Thermohaline. Temperature and salinity differences. Thermohaline. Haline. Thermohaline current. Temperature and salinity. That's the largest flux of water on the planet. I forget, maybe I can find this number. Hold on. I got a number. Crap. I can't find my number. Something like 3 billion gallons of water per second are sinking in the North Atlantic. It's not all in one place, you know. It's not like a big old, like sucks down boats. But like the North Atlantic overall is sinking water because it's losing so much temperature and getting so much saltier that the thermohaline differential drops that water. There's a general downdraft in the Atlantic and a general upwelling into other places, so the water moves. And that water moving, that makes an air conditioner and a heater. Students, what does a heater do? Yes, it makes you warmer by bringing heat to you, right? And students, what does an air conditioner do? It makes you cooler by taking away heat. Everybody understand that? So look, air conditioner for India and Alaska, heater for Europe. You got to know those. When the current works, air conditioner in those places, heater in that place. Yeah, you can see it happening right here. Look, that hot water is all over here now, so it's brought heat over to this side. You see how there's red right there? You all see that? Oh, there's a red on top? Look over here, quick, it's gonna become purple in a minute. See how the red came over? That's heating, right? Because it used to be cold and now it's getting hotter. Put your finger there, that's kind of warm. And then over here, this used to be warm water, but you see all that blue that spilled in? That's all mixing up, turning purple? Air conditioning. We cooled off the hot, we heated up the cold. The thermohaline current works as a heater for Europe and a cooler for Alaska and for India. And technically they're those parts of the ocean, so then we got to figure out what's happening with the winds and stuff. But basically this is good and good and good and good because we're used to that. So Alaska, you know, with all that upwelling and taking away all of that, the heat, moving it elsewhere, Alaska is like a pretty good place to do your fishing stuff. Alaska has relatively productive and relatively sustainable fisheries. Compared to many regions of the world, Alaska is one of the most productive fishing regions, like the general North Pacific area.
Like, why wouldn't India do it? Like,
the Indian Ocean is, yeah, by the way, spectacular, yes. Especially that part of the Indian Ocean. Some parts of the Indian Ocean are totally dead water. But if you wanted to find the best Indian Ocean fishing, you go to the part where the upwelling happened. Yep, we're used to that. And by the way, we're used to that kind of Europe. I don't know if anybody's ever thought of this before. I hadn't until someone mentioned it to me. And it's hard for you to see. If you're over there, you might need to stand up real quick. Look at this stripe across the world, right there. The stripe of latitude that includes England. If you can't see, you should get up. Look at that stripe. What does that stripe include? Mongolia, whatever the hell that is.
like all right.
Like North, yeah, Russia, North Canada, like North British Columbia, parts of Alaska. That's all like cold, permafrost, snowy steppes. And right in the middle of that stripe, we have like Ireland and Scotland and England. Does Ireland and Scotland and England remind you of southern Alaska and like northern British Columbia, like the Yukon Territory? I don't know if you know anything at all about the world, but the Yukon Territory is like permafrost and like polar bears and like Russia has those like babushka hats, you know, that are made of rabbit that like keep you warm because everybody wears those like crazy furs and drinks all the vodka because life sucks. That's pretty much Russia, right?
Yeah.
Nailed it. You guys know that Russians have the highest alcohol consumption by orders of magnitude in the national average?
Yeah.
Seems always fun though.
I was looking up babushkas.
It means grandmother in slang, and it also is a type of hat made of rabbit pelt. Put your phone away.
Are you sure it's rabbit?
Yes. Put your phone away. Write yourself a note and check some other day. Put it away, Tim. Not on your desk, Tim. But England is totally unlike the rest of the latitude. Think about like England, Scotland, Ireland, like fluffy little sheep running through bucolic fields of like grass and roses and stuff. Doesn't that not make sense, that latitude? I mean, England is pretty darn close to the Arctic Circle. You can go to northern Scotland and like be in ice flows in like one day of casual motoring on a boat. It's because of the heater. But this would stop if we could make the North Atlantic colder. Wait, no. If we could make it hotter so that it stops sinking, right? Or it would stop if we could make the water fresher. Does anybody understand why making the Atlantic fresher would keep it from sinking?
Because cold, salty water.
Salt water sinks because it's full of all that salt, which makes it heavier, but if it was fresher water, it would have to float, right? When it rains in the ocean, there's a layer of fresh water floating on the ocean until it gets a chance to mix. So here's a crazy fact. If our planet heats up, that happens. Because there's one gigantic source of fresh water called Greenland right there. You see, look again over there. There's your Europe that's unusually hot. There's your Canada that's like Canada. And then you see that huge glob of white? That's like one of the largest ice sheets on land and flirting with the ocean anywhere on the planet. And on a heating planet, Greenland melts, and by melting, it adds fresh water to the Atlantic, and by making the Atlantic fresher, it can't sink anymore, and you stop powering the current. And newsflash, that's been happening for about a decade. It got really bad a few years ago when all three of those temperature changes stopped. You might want to write this down. On a hotter planet, Alaska loses the air conditioner. And that's happened. We have more water vapor entering the jet stream. The North Pacific has slowed its upwelling rate. On a hotter planet, you've stopped this current about 60% less flow rate than it used to have historically. So number one, Alaska has lost its air conditioner, it's lost its upwelling, not entirely. India, likewise, has slowed the upwelling, which means there's more hot water left there. It's not being carried away. So India has had the wettest monsoons ever in the last 3 years. Bangladesh just had the deadliest monsoon season ever last year. Number two was the year before that. Deadly flooding in Bangladesh keeps getting worse every monsoon season, breaking records. Because all their hot, steamy water is being kept there instead of flowing to Europe. And Europe has had the 2 coldest winters. We've turned off their heater. And that's the one detail that's tough. In a planet of global warming, Europe gets colder. Because we turn off their heater, and all that heat stays somewhere else. You got to be able to explain that on the AP test. Yeah?
I went to London last spring break, and it was snowing.
No kidding! And that's not normal? Look, everybody, I did not pay him to say that. Say it again, Mark.
I went to London last spring break, and it was snowing during the day in the city.
I didn't make this up. Some people have the audacity to doubt climate change, but it's just this gigantic body of information that's extremely robust and well considered. There's all sorts of questions and mystery in the universe. Of course, we cannot explain gravity, but we don't doubt gravity. It's got a pretty good empirical track record. Every time you trip, you pretty much hit the ground. I got all the broken bones to prove it. Are there any questions about the thermohaline ocean conveyor belt current? Are there? No? Quickly, I want to do study goal number 19, which is just one interesting little fact, and then we'll spend the rest of the day on number 20, which is 3 stars. This is number 19, your figure 23.8. It's called the Keeling curve, named after a guy named Charles Keeling, who died 11 years ago but was a really big deal. He measured carbon dioxide in the upper atmosphere for 40 years straight. His lab is still making these measurements, but he died at that point. Yeah.
Here goes my construction project, making noise. Ruining it for everyone.
There's a few interesting interpretations that you could make of Charles Keeling's data set, called the Keeling curve, figure 23.8. This is study goal number 19. If you look up, you can see that on average, CO2 has been rising nonstop since the year he started, 1959. But even more interesting, you can see that every single year, CO2 goes up and down a little bit. He's measuring the entire atmosphere's CO2. Why does it go up and down every single year? What? Say it, what?
No.
Fine, don't say it. Anybody else? What? Come on, somebody. What happens every single year that might affect CO2 levels up and down? What? Seasons? It's got something to do with seasons, but do you realize that if you measure global CO2, the opposite season happens in the other hemisphere? Like right now, it's fall in Argentina. Does the planet have a season?
Oh, maybe like it's not like a tail or something. Like it's closer to the
So, global CO2 goes up and down in the different months of a 12-month year because summer in the north hemisphere is not the same as southern in the southern hemisphere. You'll remember the difference between the hemispheres? The north hemisphere has a lot more, what? People living on a lot more land.
The south has a lot more waters with them.
South has a lot more waters. What's that got to do with CO2 now? Why would that affect CO2 levels throughout the year? More CO2 what?
Yeah.
All right, get ready. The southern hemisphere has more water, and algae soaks up the most CO2. So when it's summer in the southern hemisphere, global CO2 dips. Because the southern hemisphere has more algae, more ocean, its summer uses up more CO2. North hemisphere summer has more land, and plants don't eat nearly as much CO2 as the ocean does. So in northern hemisphere summer, there's CO2 left over. And globally CO2 goes up in our summer, down in southern hemisphere summer because they suck up more CO2. That's why there's breathing within that padding. Yeah.
What does the summer have to do with it? Just because there's more sunlight, like for the algae?
Summer means more heat, more sunlight, so algae is more active, you have more photosynthesis. But overall, the southern hemisphere does much more photosynthesis than the northern hemisphere does photosynthesis. Because there's more ocean there, so there's more algae, and algae soaks up a lot more CO2 because there's more production of the ocean. How many of you find that interesting? For me, that was totally mind-blowing. By the way, I explained this wrong for like 8 years of my class. And some smart-ass kid was like, yeah, but the ocean's more productive than land. And I'm like, oh. And I was getting ready to fight them, like, you shut up. And I was like, oh, wait a minute, you're totally right. And then I verified on Google, and now I say it right things to some kids. It's counterintuitive, right? Like, more plants, more land. That's what we think of, but the ocean's much more productive. So the southern hemisphere drives that pattern. Okay. What's happening here? Somebody give me the warm-up. This is 3 stars, by the way. Number 20 is the rest of today and much of tomorrow.
Gas was getting trapped inside a layer of gas.
Let's assume that no specific difference in gases. What else is happening there? How does a greenhouse work? What's being trapped?
Retains heat.
Heat is being trapped? Where's that heat coming from? It's not coming from the sun.
From the surface, from the light on the surface. The Earth's surface. The reflection. The light.
Get ready. If you can't explain, you'll have to write. Watch. The sun gives us light. Some amount bounces off, but some amount of the light makes it in through the glass of the greenhouse. The light is absorbed by the floor and the table and the plant, and they radiate heat, the red lines, the infrared. You should know, please look up, that what we get from the sun is not its heat. We get its light, or ultraviolet. The heat is radiated by the Earth's surface. Infrared comes off things that have been lighted. Some amount of that heat escapes. Whatever you have left is called the greenhouse effect. Sure. Heat is radiated.
From like the surface of the
Yes, and the surface of the ground and the plant and stuff.
and then that heat is trapped inside the greenhouse.
And then that's trapped because, it's made of glass.
But some escapes.
I don't want this to be mysterious. I used to keep orchids for a long time. When I was a university student, I helped manage UCSB's greenhouse complex for biology. So for me, greenhouses are a really clear and obvious example. How many of you have never even been inside a greenhouse? Wait, everybody else has been in a greenhouse except 2 students? You've all been in a greenhouse except for 2 of you? Well then, bravo! Excellent news. If you don't remember that, maybe you've seen them in movies or you've heard about other people's experiences. Look, the light goes in, the heat does not escape. Light comes in, heat does not go out. This is why your car gets hot when you park it outside with the windows closed. Light enters the car, heat stays in the bubble of the car. And unfortunately, we environmentalists in our 1980s, 90s, and millennial panic, we've used every possible word to describe our problems, but technically the greenhouse effect is not a problem. The greenhouse effect is the only reason we have life on Earth. Mars is over 300 degrees in the daytime and under negative 200 at night. Mars has temperature variation of about 535 degrees in a 24-hour period at its equator. 535 degree temperature spectrum from the hottest hot to the coldest cold in a 24-hour period on Mars. Life would not work there. You realize that, right? Everybody understands that at 300 degrees you evaporate, right? I mean, most of your water evaporates. And everybody understands that at negative 200 degrees, you can't function either.
How would we be able to go?
I can't hear you. What?
Would we be able to go to Mars? We can't go to Mars?
Well, it's pretty difficult. Not only the mechanics of reaching Mars, but it's not like you can hop out of the space shuttle on Mars and be like, all right, party time. Because it's a very hostile environment. Yes?
Is the greenhouse effect just like big people to release?
Oh!
Or what's it?
Erlia says, what the greenhouse effect? That the greenhouse effect. So sunlight goes in, made into heat, and of that heat, a lot is retained. If that one doesn't help you, maybe this one helps you.
So it's just like the released heat from like the surface absorption and stuff.
Yeah, right. This is what we call the greenhouse effect. That arrow pointing down. All planets have the light coming in and heat going out. What makes the Earth special is we keep some of that heat in there. That moderates temperatures.
So with the loss of the atmosphere, like, even with the atmosphere, what's the potential danger of that?
Yeah, what's the danger of all like the greenhouse gas?
Greenhouse gases are rolling up the window in the car, keeping more of the heat, not letting the heat out. You see what I mean? Does everybody see that red arrow bouncing off the Earth? Please tell me that you see the big red arrow bouncing off the Earth, for God's sake. That's heat escaping into space. Greenhouse gases trap more of it, like rolling up the windows in your car in the parking lot. Or like closing the vent at the top of my greenhouse. That's the greenhouse gases. More gases, less escaping heat, more heat stays in. Yeah.
If we were to like put greenhouse gases on other planets, would it potentially create an atmosphere?
Yes. Look, my wife and me, we have this struggle. Well, we have a lot of struggles. But this one that I care to mention right now, she's afraid that people will break into her car and steal things. And she feels that by closing the window, she prevents theft. I argue that she might be right about some thieves, but for me, I hate closing my window that last inch because that's what lets all the heat out. And I have a very sensitive tushy region. And I don't like to sit on really hot seats. And I hate sweating. Sweating is gross. I sweat enough as it is. I'd rather be 100 degrees too cold all day than be 1 degree too hot for a minute. I hate heat. I can always warm up. I cannot cool down. I'm basically a big, fat, hairy walrus. I'm not really afraid of the cold, but I just can't deal with hot. So every time we leave her car, I always like, as she's like turning the key, I like press the down window button. Oh, sorry, might be. I leave the window down. She's gotten to the point where she'll psych me out. She knows it's coming. So when she's getting ready to get up, she'll go like, and watch me, and then go, aha. And then she'll roll up her window and then get out. Life. Yes, Elia?
Is that heat that's lost, is that not bad for our?
Okay, so Erlia says, isn't that lost heat, does that have anything to do with our life? Well, if we keep that heat, we will be a hotter planet. Like if my wife succeeds at rolling up the window of her Subaru, we'll get back into a hotter car. That's a clear analogy, right? You all understand cars and windows, right? Globally, we are adding gases equivalent to closing windows. That's all the mystery you need to know of climate change. Yes?
So more heat being absorbed by the surface isn't really the problem, it's the separation that is like messed up, especially how much is lost and how much is gained.
Well, it's tough because if you shoot a cancer patient, now they're dying of a lot of things. Our planet is, first of all, keeping more of its heat, but second of all, when you lose ice, you expose soil that is darker. So separately, we're also making more heat. You understand? Watch. If you had a mirror in here, the greenhouse would be colder. Right? Because you're not absorbing any light, it's the mirror. If you get rid of the mirror, you absorb more light and make more heat. Earth has two problems now. Greenhouse gases have closed this, and because it's getting hotter, we're losing ice, which is raising the amount of heat being made on top of everything else. Shot the cancer patient. Another problem on top of your problem.
Does that have anything to do with like something about how like then you have to use more energy for air conditioning?
Yes. Yes. Anybody want to ask me anything about this? Because I've got about 7 minutes to smash Serena's phone on her face and then finish this unit. Questions? Okay. We know, and you can verify, that all those gases which make up our heat window are being added by human activity. You can pretty much get a curling iron and a Mylar emergency blanket and some helium from the greeting card joint, and you can make a weather balloon, and you buy a spool of Dacron for flying kites. And if the airplanes don't hit it, you can fly a high altitude weather balloon and mount a little sensor that measures CO2, methane, chlorofluorocarbons, perfluorocarbonates, a trillion other greenhouse gases that are all rising. And if you don't believe me, you can calibrate your own data. Go ahead and prove the conspiracy wrong. Very doable. And I've got just a couple minutes to make this point, and I know that I'm not really arguing with you because people in your generation don't really doubt climate science. I'm having a debate with someone who's not here. But there are those people, you know, some of whom running for president today, who dispute science and say that this is fake. But you should know there's nothing uncertain, and it makes a big difference. People's lives are at stake, even in your country. First of all, climate change was discovered by a man so long ago that I can't show you a picture because he died before the camera was invented. And the experiments on greenhouse gases were done by this crusty old fart using this crusty old homemade lab equipment. He couldn't buy commercial glassware because there wasn't commercial glassware. But he already showed that some gases absorb energy, their bonds destabilize, and as their bonds restabilize, they re-emit that energy. It's called a greenhouse gas. When you take chemistry 200 in university, there's different names. A molecule with like H2O, H2O, okay, water. Watch, when you heat up water vapor, those bonds wobble. And there's different kinds of wobble. There's this wobble, there's this wobble, there's this wobble, there's this wobble. I don't know which one water does, but when you heat up water, it wobbles, and then those bonds restabilize, and that heat comes off. That's what greenhouse gases do. That's what we mean by trapping heat. They absorb it and they re-emit it. You understand what I mean? Look. Heat rises to the atmosphere, those gases absorb it, and then they re-emit it back to the earth, okay? This guy figured it out. This guy wrote in the New York Times, not even science publications, the year after my father was born, that fossil fuels were going to change global climate. And then he started a lifetime pursuit on top of a volcano in Hawaii to measure CO2 because he knew he'd be right. And he was. He's this guy. And just so you know, it's not like he's like some lone wolf who measured CO2. Since this science goes back to like the 1800s, climatologists have been measuring all the greenhouse gases for many decades, and they've all been going up. And the pattern that they go up matches perfectly our climate records on the planet. And people are like, well, I don't know. Isn't there like some like shaky, we gotta wait, I'm not sure, we gotta wait. Oh, I'm gonna wait until the evidence is in. Classic quote by presidential candidates. Really. Ocean temperature, sea level, global temperature, Arctic temperature the last 2000, look at the right. Arctic ice pack in the last 40, Arctic ice mass overall in the last millennium and a half, look at the far right. The amount of Greenland which is disappearing over the last 40 years, the change in the mass of the Greenland ice sheet, the ocean conveyor belt has slowed, and those weather patterns we talked about, global average temperature last century and a half, global average temperature the last 11,500 years, and people are like, well, I don't know. I'm really not worried about it. I don't believe, people say. We can't treat this like a belief issue. Look, kids, I can't explain every detail of gravity. Does anybody here not believe that my keys are going to hit the ground if I let go of them? I mean, okay, well, I told you so. But wait, maybe this time. What kind of an idiot would make that a matter of belief? That's like saying I don't believe in rabbits. Like, nope, evidence says that's a rabbit, but I don't believe in rabbits. But okay, then what are we looking at? It's not a rabbit. If you poll US scientists, world climatologists, if you run a survey of the surveys that have asked scientists, there's really no doubt among scientists that humans are causing changes in climate, but the media is not helping us. Because of equal and balanced, fair reporting, 72% of mentions of climate change include a skeptic. So then you ask Americans, are you skeptical? And 74% of Americans say, yes, I am skeptical. If they said they were skeptical of rabbits, we would think that's absurd. But the basics are easy, and you've got to know this. There are gas molecules that accept and re-emit energy. They're called greenhouse gases, the wobble issue. I guess we're going to have to do this tomorrow. I'll come back to this. Remind me, the basics. Somebody believes in rabbits. Good. What about rabbits, Grandpa? What about gravity, Grandpa? You went gravity, bro? I had this yesterday.